There we go. All right, so we are going to do a review today is 419, and it is the probability review, okay? So number one, so if you're going to randomly draw a marble, so first of all, what I like to know is what's the total. Knowing the total helps, okay? So there's 8, 6 makes 14, what's 14, and I'll just add it up, 14 and 13, so that's 27, I think. Let's double check. 8 plus 6 plus 8 plus 5, so I get, yeah, 27. So there's a total of 27. So knowing the total, what's in the bag, really helps, okay? So what is the probability of drawing a green marble? That should be easy. It's just 8 out of 27, right? Nobody should miss that. Okay? 8 out of 27, right? You've got a possibility of 8 of them you can grab out of 27 marbles. What's the probability of drawing a green and then a red without replacement? So if it's without replacement, the second drawing is going to change. The bag's going to change. So first, let's just grab a green. So the green is 8 out of 27. But once I...
Wouldn't that be 6?
Green. There's 8 green. That's okay. So there's 8 green. So, but once I pull that green and put it in my pocket, the bag changes, right? So then the next one is out of 26 because now there's only 26 marbles in the bag. That makes sense, doesn't it? Yeah. And then how many exactly? How many red do we have? We've got 5. And so we have to multiply our probabilities. Okay, so the answer is going to be 40 out of, I don't know, what's 27? Yeah. And if you want to change that to a decimal or a percentage, that's fine. You can leave it as a fraction. For me, that's fine, okay? Now, not too bad. You guys agree? This isn't so bad. C, what is the probability of drawing a marble that's not green? Well, if it's not green, it's all the rest of them, right? So I know there's 27 marbles in there, right? So there's 8 green. So if we're going to draw everything but 8 green, there should be 19 other marbles. That makes sense? So I'm just taking my 27 minus my 8, right? Which makes 19. So if I'm not drawing a green, there's 19 other marbles in the bag, right? Okay, how am I doing? Thumbs up? Okay. Now, number 2 is easy. You just have to understand the question. You're asking for the complement. Okay? So if it's 0.35 is A, its complement is just simply 1 minus 0.35, which is a 0.65. The complement is just the other probability. This is the probability to win, and that would be like the probability to lose. So you just subtract 1 from it. That's all you do to get the complement. This little bar right up here means complement, okay? That's the symbol for complement, okay? So you just subtract 1 from it. Okay, that gives you the full probabilities, right? You got a 35% to win, so that means you'd have a 65% to lose. Okay, how am I doing? We're doing okay? Okay, 3. Odds are kind of tricky, but what happens with odds is this: you have a 1 chance to win and 19 to lose. That's what odds are different. They don't give you the total, but if you really do have 1 to win and 19 to lose, that means you have a total of 20 possibilities. Does that make sense? So as far as a probability, so the balloon toss as a probability would be 1 out of 20. 1 out of 20 to win, okay? Odds are different than probability, okay? I know that there are a total of 20 possibilities because I got 1 to win and 19 to lose, which means I got a total of 20 balloons. I got a total of 20 balloons. So 1 out of 20. If I do that as a decimal, what is 1 divided by 20? I get about 0.05. So which is better? 5% or 20%? Which one's better? Well, the lotto, of course, because that one's 20%. If that was 20%, that's much better. So let's answer this by going the lotto game. Lotto game is better. Okay. All right. Number 4. find each probability from like a 12-sided dice. Now, it's 12-sided dice, right? It's not a regular dice. It's 12-sided dice. So you roll a 5. How many fives are on a 12-sided dice? Well, only one, right? Only one. So it's just 1 out of 12. How about an even number? Well, let's see. There'd be a 2. We'd have a 2, a 4, a 6, 8, 10, and a 12, right? So there's 1, 2, 3, 4, 5, 6 out of 12, or 50%, right? Or 50%, right? How am I doing?
Great.
Okay, Katie, thank you. I want you to do well on this. If you're willing to take the notes, pay attention, you're going to be okay, all right? Okay, 5A. Okay, 52. Okay, if you don't know cards, then this is always difficult. But I always assume most kids know what's in a deck of cards.
50.
Every now and then you got a kid who doesn't, and then that makes it really difficult. But I always make the assumption everybody knows what's in a deck of cards, okay? So, you draw a black jack. How many black jacks are there? How many black jacks are there? 2. Everybody agree with that? Just 2? 2 out of 52. Okay, 2 out of 52. Okay, and this word should be here. I should have typed that better, but you draw an ace, then a blackjack without replacement. So I'm gonna take an ace out. Okay, how many aces are there? 4, right? Out of how many cards? Okay, so 4 out of 52. And then I'm gonna take the ace, pull it out of the deck, put it on the table. So there's no longer 52 cards, are there?
No, there's
51. 51. Because I only took one ace out, right? I only took one ace. Now I'm going to try and draw a black jack. So how many black jacks are in the deck right now? 2. 2, right? So we just multiply 8 over what's 52 times 51, 2,652. Sure. Sure, there you go. Okay. Okay, number 6. Oh boy, we had that formula.
Goody boy.
I can use my journal because my journal's got the formulas in it, right? So I see the word independent. I see the word independent. Okay, so I'm going to try and find, I think it might even be section 5.1 or 5.2. So I'm going to look at my book. Because I mean, if I don't have notes, I can find my notes in here. 5.1. Okay, I'm looking for, hey, there's that formula. What do you know? There's that one. Hey, there's that one, right? The complement. We did learn that one, didn't we? And then I'm looking, oh, it must be in 5.2. Oh, here we go. There's independent events. Look at that. Independent events. So my formula is P of A and B is equal to P of A times P of E. So I'm going to write that down. I'm going to actually write that down. 163. I'm actually going to write that down because that might help me, okay? So what I found in my book was P of A and B is equal to the probability of A times the probability of B. Okay? So I can just use my formula, right? I'm going to set up number 6. So I've got 0.12 is equal to 0.30 times P of B. All right, so I'm going to go ahead and use my formula. P of A and B is 0.12, so I put that there. Okay. P of A is 0.3, I put that there. And I don't know P of B because that's what I find. And I'm just going to solve like I solve for X. Just like solve for X, I'm going to go ahead and divide by 0.30, divide by 0.30, right? And I'm just going to use my calculator. 0.12 divided by 0.3, and I get an answer of, hold on, 0.3 divided by, I'm doing it wrong, 0.12 divided by 0.3, and I get an answer about 0.4 is the answer for the probability B. Okay? Not bad, I just solved, right? Yeah. I just solved. I said 0.12 is equal to 0.3 times B, so divide, and I get 0.4, okay? Let's see, A and B, it looks like a formula, are dependent, right? So I'm looking for, in my book, dependent. So, alright, so in my book, I find it on page 164. So there it is on page 164. So probability of A and B is equal to probability of A times the conditional probability. This is like pulling the card. Once you pull the card, it changes the deck. Does that make sense? So the probability of B depends on what happened with A. That's why that's happens, okay? So if I pull a card out of the deck, probability of B is different because A affected it. It changed the deck, right?
No replacements.
Right, exactly. So, and that's what makes it dependent on it.
Replacement then.
Yeah. So my formula is P of A and B is equal to, hey Omar, Mr. Stubbs, P of A times P of B slash A. So I've got my formula, right? And I found it in my book. There it is, right? But I'm just going to write it down in my notes so I don't have to look for it later, right? So if I put it in my notes, I've got it for tomorrow, right? Right? So then, let's figure this out. So, let's see. Find P of A and B. So P of A and B is equal to, let's see, P of A is 0.15. P of B conditional A is 0.35. Well, that's pretty easy. I'm just going to use my calculator and multiply those, right? So I'm just go, okay, I can do that. I'm just going to go 0.15 times 0.35, and I get an answer of 0.0525 as a decimal, okay? That was easy. We just needed the formula, okay?
Wait, isn't it supposed to be A divided by B or B divided by
This slash right here, great question. That slash is not a divide by. It means conditional, okay? And it's like the deck of cards. Okay? I want to do two experiments, right? I want to draw an ace. Okay. Let's draw an ace. So draw an ace, okay? So the probability of B now is affected by A because I just changed the deck. That's what this means. It means probability of B is, it's conditional on A. That's what this means. Does that make
So
sense?
why do they use a slash mark?
I don't know. How's that for an answer?
It's the same as dividing.
I know.
Confusing.
I know. Mathematicians like symbols, probably because we can't spell. How's that for an answer, huh?
No, I got that. I just don't understand why they use the same one.
Yeah. There it is. You see it here? It's right there, right?
Well, it's backwards.
A times like an X.
Right.
You just wrote it once.
Did I?
Divides that way. This is a backslash.
Oh, should be straight up and down, right? Yeah, it should be straight up and down. Tim, if I'd written maybe more like straight up and down, that might help, okay? All right, you guys ready to turn the page? All right, turn the page. How are we doing? Okay? All right, now, 10 books need to be lined up on a shelf. 4 are fiction and 6 are non-fiction. Describe the meaning of 10C4. So, really, the big key is this, and you need to write this, okay? You need to write the fact that we're going to line up 4 fiction in, you ready? Any order. Any order. Okay? The order does not matter. If it's a combination, the order does not matter. Does that make sense? If it's a combination, you can say, okay, it's as simple as this. I'm going to write it down so you can see it, okay? You can say it's, you've got, is it non? Yeah, it's fiction. You got fiction, 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 blah, 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 blah. Or you can have fiction, blah, 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 fiction, blah, 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 fiction, blah, 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 fiction, blah, 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 okay? So, they're the same, okay? Fiction, 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 okay? Do you see any difference between these two? You don't. This is fiction, fiction, fiction,
Well,
fiction.
there's dots.
And then these are all the non-fiction. I just want to write them down, okay? Okay, I'll explain it better. So I got 4 fiction books. I put them on the shelf. I want the 4 to go to first, so I know that my fiction are right at the beginning, right?
Yes, sir.
This could be Moby Dick. This could be, I don't know, this could be Bambi's Little Surprise.
What?
But the order doesn't matter, does it? Okay, the order does not matter. Now, what is this? So now, you've got your calculus. There's 2 ways to do this. One is, and I'll do it up above, one is 10 factorial divided by 10 minus 4 factorial. That is one way to do it. Or let's use the calculator.
Calculator.
So to find the calculator, I'm going to look at math, and I'm going to find the probability, okay? Now, before I do that, though, I got to put the 10 down first. So my calculator, let me show you how I'm going to do it. My calculator. Yes.
What's like the exclamation or
Factorial, which means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, that's a 6. You agree that's going to be a number 6? 6 times 5 times 4 times 3 times 2 times 1.
Just go from that number down.
Right, exactly.
Oh, and then you have to subtract and whatever's left on top is what you get.
Now, I can do this with my calculus. So the answer is really whatever 10 times 9 times 8 times 7. I mean, it really is. Right? You could go 10. Can you guys see my calculator? Yeah, you could go 10. I'm going to show it. I can go 10 times 9 times 8.
Is 5,040.
Right? Or you want to see how you calculate it? So I can go 10, math, probability, and there it is, right? My P, enter, and then 4. Same answer, right?
Yeah, but that's a lot more work.
So you can either do it by the formula and do it by hand, or just let the calculator do it for you, okay? All right? Now, 9.
Will you please wait for a second?
Yep,
Thank you.
I will. So these two are different. I'll wait for you, okay? These two are different.
Math 1.
Okay? Yeah, math, then probability. Math, your buttons on your calculator are math, then probabilities. You boys have to keep your hands to yourselves, period. That's why you're up front.
Can you maybe
Just separate them into corners, please.
We'll take that.
Like your number.
Okay.
For Michael White.
Okay.
He's always predicting.
Now,
Is that top one?
you having a bar?
It's like that one.
that one's for the combination.
Yeah.
I'm with you.
Oh yeah. Yeah, this was, I just did the P. In fact, I did it in the calculus P. Yeah, this is the P. This is the P. 10P4. All right, now, with the P, this is called a permutation. The order is important. The order is important. So watch. Let's say my 4 nonfiction books are, I don't know. Maybe it's Bambi. I'll use Disney. Make it easy for. Maybe it's Bambi. Maybe it's Aladdin, right? Maybe it's
Frozen.
Frozen, and maybe it's maybe another one.
No, not Frozen.
So the order would be different. The order would be different because if this is okay, watch. Don't A B C D or C D B A. The order is different, isn't it? This is a different set, isn't it? Right? It's a different set. So if the order's important, then you're going to have a different thing. It's called permutation. And you're going to use, for permutation, you're going to use this one. So if you're going to describe the meaning of this, you're going to say, for fiction books in order. Okay, you got to use the word order. I'm looking for the word order. If it's permutation, order is important. And you get more combinations. So then you're going to use I did that one. I did the P. This one's the combination. So we'll do the combinations up here. We'll do this 10C4 here. And the 10C4 looks like this. That's got the, I'm running out of room, but I'll slide it over here. So let me do both. Let me do the 10C4 and the 10P4. Okay, that one's going to be my 10 factorial over my 10 minus 4 factorial times. Cody, keep me straight. Right, that was that one.
Wait, should we write this down?
I don't know if you're going to need to, but you might. Okay, now, or you can use your calculator, right? Right, you can use your calculator on either one of them, which makes it pretty easy. So if I do this one, if I go my 10, go to math, probability, right? And I use the C1, 4, I get that answer, right? 210. This one's my 210. And the other one was my 10 math probability. Here's my P. And then I do my 4, and I get an answer of 5,040. And it makes sense. If order is important, I should have more combinations. Because, think about this. You ready? Check it out. These are different. That's two different permutations, right? If it's all just fiction, 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 then they're the same. There's less choices, okay?
Yeah.
So if it's a combination, there should be less choices because 4 fiction books, no matter how you put them together, is still 4 fiction books, right? But if it's 4 different fiction books, you get more combinations, more permutations. All right, should we move on?
No.
Nope, I'll wait for you, okay? And your calculator can do that, right? Let your calculator do the work for you, okay? Okay, number 9, I'm going to have to do on a separate sheet of paper, okay?
Is that 2 or a 7 at the top there?
2.
Okay.
2.
Sounds like.
Put your hand.
Okay, number 9, boys. Number 9. Okay, now number 9. There are 18 men and 20 women. So I'm going to make a chart. It says the marginal frequency. So I'm going to make a chart like this. Okay? We're going to put men. And we'll put women. Okay? And it seems as if they are voting on 2 benefits packages. We got package 1. Nope, sorry, I got to put that up here. Package 1. Where's my whiteout? Put that in the wrong spot because I need some numbers there. Need some numbers there. Package 1. And I need a package 2. Okay, and then I'll have some totals. Okay. So let's put in what we need. So first of all, there's 18 men. Put an 18 there, right? 22 women total. Oop, I did that wrong again. 18 men, 22 women. 15 men voted for the package.
Okay.
Okay. 14 women voted for the package. Does that make sense so far, right? Package 2 would have to be 3 and 6, 7, 8, right? How am I doing?
Good.
It actually makes sense. It's not that hard, right?
Good.
So I get my totals. My totals, let's see, that's 29. And that's going to be 11. And that's going to be 30. 40. I can't add. 40. Okay, now, from this, we can do some probabilities. Okay, so what is the probability of men voting for package 1? Okay, men voted for package 1. Well, how many men voted for package 1?
15.
Out of how many? Out of how many people?
So then we...
Out of 40.
Oh, right. Oh,
40.
Right? Package of women that voted for package 1. 14 out of 40. Okay?
Whoa.
Right? Isn't this easy?
Yes.
Right. Okay, this should be easy. Everybody should be able to do this. So this one's going to be worth 6 points. So you're going to get 2 points for the chart, and I'll have 4 probabilities. This one should be easy. Should be easy. You guys agree?
I agree.
Okay. I'll wait for you, Bijou. I'll wait for you.
Yeah, can you leave it there for a minute?
Okay, number 10. Here comes the hard one, and we'll go through it slowly, okay? Number 10's the hard one, but we'll do it slowly, okay? All right, Bijou, you ready? All right, number 10, and we'll go through it slowly, okay? All right, 10. We're going to draw a histogram. We're going to have to draw a histogram, right? A binomial distribution, okay? So if we're going to do a histogram, the first thing we have to do is come up with all the combinations, okay? So list all the combinations. So let's start off with this, okay? We've got 4 students, right? And 25% have an ASB, which means 75% don't. Do you agree with that? Let's just start there, okay? We're gonna survey 4 students, only 4 because we don't have time for more than 4 because we're busy, right? So the thing is, if we're gonna go 4 randomly in the whole school, there's lots of chances, right? We could find 4 that don't have an ASB at all, right? We could find only 1 that has an ASB. We could find 2 that have an ASB. We could find 3 that have ASB, or we even could find all 4, right? Chances are, with 75%, that we'll probably find maybe 1 or none that have an ASB. Does that make sense with probabilities? Okay, so we're going to do this. We're going to say, okay, we could have 4 kids that don't have an ASB.
Okay.
We could have 4 kids where 1 kid has an ASB, right? We could have 4 kids where 2 kids have ASBs. We could have 4 kids where 3 kids have ASBs. We could have 4 kids where all 4 have ASB cards, okay? Does that make sense?
Yes.
Now, these numbers are going to be taken from Pascal's triangle or from our calculator. We can do the combinations on our calculator, right? You guys agree? But for me, it's so much easier. Look, I could either use Tim's Pascal's triangle, which is awesome, or I put it on the board, right? So since there's 4 students, right? Where are we going to look? 4 students. Where are we going to look? 4 students. We're going to look on row. This one right here, right? Right. This is the zero. That's the 0 row. That's the first row, second row, third row, fourth. Okay, we'll look right here. Okay, look right there. Okay. So let's put those numbers up there, right? So I'm going to put the numbers up there. I'm going to start with 1, 4, 6, 4, 1. Okay, those numbers came from Pascal's triangle. You all right with that? These are all the different combinations of asking kids. So then, my percentages. I'm going to have a 0.25 to the. Let's see. What am I saying? Have, don't have. This would be don't have and have, right? 0 times 0.75 to the 4th. 0.25 to the 1 times 0.75 to the 3. 0.25 to the 2. 0.75 to the 2. 0.25 to the 3, 0.75 to the 1, and 0.25 to the 4, and 0.75 to the 0. Okay, so.
Why can't they just have something where you just immediately solve it? It'd be so much easier.
Yeah, I think there is something in the calculator. We just haven't found it yet, okay? Anyhow, so let's just use our calculator to get these answers, okay? So I'm just going to use my calculator to get these answers. So I will go 1 times 0.25 to the 0 times 0.75 to the 4th. Okay, oops, to the 4th. And I get an answer of 0.31 or 31.6%. Okay, 31.6%. Okay. I'm going to use my calculator on the next one, right? Just going to go, all right, clear that. I'm going to go my 4 times 0.25 to the 1 power times 0.75 to the 3rd power. And I get about 42.2%. 42.2%. Okay. So then I'm going to go 6 times 0.25 to the 2nd times 0.75 to the 2nd, and I get about 21.1%. Then I'm going to go my 4, clear that, 4 times 0.25 to the 3rd times 0.75 to the 1, and I can answer about 5%. Then I'm going to go 1 times 0.25 to the 4th